Hello bachcho, let's read this question. So the question says that present a comparative account of the alkali and alkaline earth metals respect to the following characteristics. So generally we have to compare between the alkali and alkaline earth metal on the basis of these 5 points. So first is tendency to form ionic or covalent compounds, then nature of oxides and their solubility in water, then formation of oxosalts, solubility of oxosalts and thermal stability of oxosalts. So on the basis of these 5 natures, we have to compare between the alkali and alkaline earth metal. So let's solve this question. So first is tendency to form ionic covalent compounds. So if you see alkali, so the left side will discuss about alkali compounds, then on the right side we'll discuss about alkaline compound. So first point is tendency to form ionic or covalent compound. So all alkali except lithium forms ionic compound. We know that lithium is the lithium size of lithium is very small, so it generally it forms covalent compound. But all alkali metals, like all alkali metals except lithium forms ionic compound. Except lithium forms ionic compounds. Because we know that as lithium has small size, so it forms covalent compound, but except lithium all alkali form ionic compounds. And in case of alkaline earth metal also, all alkaline earth metals except beryllium forms ionic compound. So reason is same for beryllium also, as beryllium has small size, so it forms covalent compound instead of ionic compound. So this is the first point. Now we'll go to second point. So second point is nature of oxides and their solubility in water. So solubility of oxides of alkali metals generally increases down the group as the thermal stability decreases. So solubility of oxides of alkali metals increases down the group. Increases down the group because when we move from top to bottom, top to bottom, so what happens? Thermal stability size increases and thermal stability decreases. So as thermal stability decreases, solubility of oxides of alkali metals increases down the group. And if we discuss the nature of oxides, it is the solubility of oxides in water. And if we see the nature of oxides, then lithium, all alkalis are basic. Lithium oxide is weakly basic, but others, except lithium oxide, oxides are strong bases. Only lithium oxide of lithium is weak base, but other oxides are strong base. Now we'll see alkaline earth metal. So in case of alkaline earth metal, solubility of oxides Solubility of oxides of magnesium, calcium, strontium and barium increases from magnesium to barium. Generally, it increases from magnesium to barium. Bu, and if we know that as Bu is covalent, Bu is covalent and insoluble. As Bu is covalent, so it is insoluble. And if you see the nature, then Bu is amphoteric. Bu is amphoteric, but MgO, CaO, SRO, MgO, CRO, CaO, CaO and SRO are weak bases and BaO is strong base. So this is the second point. Now we'll go to third point. So third point is formation of oxosalts. So all alkali metals form oxosalts. Oxosalts such as carbonates, sulfates, nitrates, carbonates, sulfates and nitrates. All this is also same for alkaline earth metal. All alkaline oxosalts or all alkaline metals form oxosalts such as carbonates, sulfates and nitrates. So all alkaline metals form oxosalts such as carbonates, sulfate and nitrates. This is the third point. All alkaline metals also form oxosalts such as carbonate, sulfate and nitrate. Now next point is, so this is alkali and this is alkaline. So now we'll see the fourth point. So third point, fourth point is solubility of oxosalts. So if you see the solubility of oxosalts, then solubility of oxosalts increases down the group. Solubility of oxosalts increases down the group. Increases down the group. So solubility of oxosalts such as sulfate, nitrates, carbonate generally increases down the group. But in case of alkaline earth metal, it is decreases. Solubility of oxosalts decreases down the group. Decreases down the group. So now we'll come to the last point, that is thermal stability of oxosalts. So now we'll see the thermal stability of oxosalts. So oxosalts of alkali metals are thermally more stable. Oxosalts of alkali metals. So generally we'll write it in a point. So oxosalts of alkali metals are generally more stable. Alkali metals are thermally more stable than those of alkaline earth metal. Than those of alkaline earth metal. As the electropositive character increases down the group, so the stability of carbonate, hydrogen carbonate of alkali metal increases. But whereas for the alkaline earth metal, carbonate decomposes on heating to give CO2 and O2. So as the electropositive for the alkali metals, as the electropositive character increases down the group, the stability of carbonate also increases. Alkali metal also increases, whereas the alkaline earth metal, the carbonates of alkaline earth metal are unstable, whereas for alkaline earth metals, carbonates decomposes on heating to give CO2 and O2. So these are the basically the points in which you can compare between the alkali and alkaline. We know that the ionic character or the tendency of ionic character is more in case of alkali as compared to alkaline. Also solubility is also more than alkaline metals, and also solid formation of oxosalts or the stability or the thermal stability of oxosalts are more in case of alkali as compared to alkaline. So these are the 5 points we'll discuss as compare between alkali and alkaline earth metal. Hope you understand it well. Best of luck.